An elevator cab and its load have a combined mass of 1,600 kilograms. Find the tension in the supporting cable when the cab, originally moving downwards at 12 meters per second, is brought to rest with constant acceleration. At this point it's deceleration, but who are we to judge? In a distance of 42 meters. So this is a dynamic question that starts with a kinematics part. The kinematics part is straightforward, which is, we'll use the equation v square equals to u square plus 2as, because we don't care about the time too much, so this is the best equation to use. Now over here, v square is actually 0 because it's gonna, the final velocity will turn into 0, right? So that, just make that point over here, and you have 12 over here, and a you want to find out, and the distance is 42 meters, right? So it slows down, so it's probably a very low deceleration or low acceleration. And let's solve that, and what do we get? We get acceleration rearranged, and we're getting negative 1.17 meter per second square. So that's the kinematics part. We really needed the acceleration. Now what do we need? Let's look at the question again. Find the tension in the supporting cable. So it's decelerating. So the deceleration is actually caused by the wire. So it has its own weight. Yeah, so it has its own weight and it's being decelerated. So let's figure that out. Okay, it's brought to rest with a constant acceleration in a distance of 42. Okay, ठीक है. So we have the weight of this elevator as W, which we can easily find out by the mass. There is tension. There is tension on this elevator. That is upwards. That is a force T. And as we have seen, the net acceleration is a deceleration downwards, so that's a acceleration upwards. Ergo, the net force acting on this is also upwards. So with that said, let's move on and figure out our dynamics part. All right, so the dynamics part is just balancing our equations which we saw on the elevator, the first of which, or the forces are, the net force, the resultant force, is just the sum of two forces acting on it, the tension in the elevator cable and the weight of the elevator. Those are the two forces acting on it, and the net force is upwards. I'm taking tension as upwards, so that's why these two are positive. This is in the opposite direction, so it's negative. And we also know that the tension in the string will be larger. Anyway, because we have to find the tension, we'll make that the subject. And yeah, so let's try to figure out F net first. Let's see if we can do that. Right? So the net force is the net acceleration, which is we just calculated. It's upwards. So from negative, we changed it to positive. And the mass is 16. So we know very easily what the net force is, because that's how, this is the resultant force. And we know the acceleration, what the elevator is going through, or the deceleration, right? And we calculate that. Now it's time, what do we do with weight? We know the mass, so we can easily figure out the weight as well, which is going to be right here, which is the mass times the acceleration due to gravity. Straightforward. And yeah, let's make some room and actually move down a bit. With that said, it's just math from here. And yeah, let's make 1600 common. The reason I did that is some people might just find it easier to calculate. Also, it's just giving some insight as to what's going on. The mass is the same, it's only the two different accelerations, so to speak, that are being added. The total acceleration and the acceleration due to gravity. We're adding that, and that's the entire thing being catered by the tension in the wire. And that makes a lot more sense if you want to look at it that way. You don't have to, but it's very insightful. And our final answer comes out to be 17,600 newtons, or 17.6 kilonewtons. And that's our answer for this question.